Justin here. I'm in my late 40s now, and I would say for at least the last 35 years I've been a hobby junkie. It doesn't matter what it is, I've tended to enjoy it, whether it's high-end audio, radio-controlled cars, trucks, planes, helicopters at one point. I like plastic model building, I like wooden shipbuilding, I like all of that. Probably the best term I can come up with is a hobby junkie. Probably the hobby that goes back, the most serious hobby that goes back the longest for me is high-end audio. I remember almost like it was yesterday going into I think it might have been a high-end audio shop outside of Dayton, Ohio, which is where I grew up, and I saw a little solid-state integrated amplifier from an English company called Name. It was the Name Nate 1 actually, and that was and I bought it. It wasn't very expensive at the time, $275 I think is what I paid for it. It was used, and that was the beginning. Over the next 25 years, I have been intimately interested in high-end audio. Now, it just so happens that, the first 15 years of that, I was kind of a quote-unquote flat earther. I was interested in Listener magazine. Used to be helmed by Art Dudley before he went to Stereophile. Unfortunately, passed away or rather suddenly earlier this year, I think it was. And throughout that time, I owned pretty much everything I had was Name or Lin. And as a matter of fact, I still own 2 Lin turntables. I don't have any Name equipment. Maybe 6-7 years ago, I moved away from Name Audio when it kind of went to their more modern approach, and I started getting into vacuum tube amplifiers. And as it stands now, I have my main system consists of from a company, but it's a very low volume Japanese tube amplifier company called Lieben. I happen to have their small integrated amplifier and the phono stage. But I've dipped my toes into many different kinds of audio, different kinds of different companies, and after a while, from my perspective, I guess I got bored. I realized, seems like I would have realized this sooner, but I could always spend more money and get presumably better sound, but it wasn't really bringing me any more enjoyment. So about 2 years ago, I kind of extended this hobby a little bit, and I got into rehabbing vintage vacuum tube audio equipment. Now, when I started 2 years ago or so, I knew nothing about how to rehab vacuum tube audio equipment. Everything that I have learned off the internet, mostly, believe it or not, through YouTube. As a matter of fact, pretty much everything I know was taught to me by Uncle Doug on YouTube, and that's not an indictment of Uncle Doug. If he taught me, if he tried to teach me 100 things, I probably only picked up 25. But anybody who's sort of interested in learning about that, that's a great way to start. He probably has 15 videos that are simply essential to figuring out what you're doing under the hood of vacuum tube audio equipment. In any event, I have rehabbed, probably a dozen, maybe a dozen and a half of, vintage equipment, Fisher, Scott, Harman Kardon, Sansui, all that stuff. And I started to get the itch again, maybe, I don't know, 2 or 3 months ago, and I thought, well, this stuff sounds pretty good. I enjoy what I'm doing. I understand it enough not to kill myself in any event. And I thought, okay, well, let's see what I could do if I build my own amplifier from scratch, and that's exactly what I did. It just so happens that about 6 months ago, I picked up a couple of Ampex box amplifiers. So I believe the model was 620 or 621, and these consisted of 6 V6 push-pull vacuum tube amplifiers inside a wooden box that has a single speaker driver in it. The driver was made by JBL, and the I suppose the tricky part of this is that the amplifiers included a compensation circuit in them in order so that they would sound good with this single JBL driver. And what I did, I knew I wasn't going to utilize them as they were, although they actually sounded pretty good. I pulled the amplifiers out. I ended up getting rid of the boxes, and I thought to myself, well, you know what? This stuff is pretty well respected. The iron is pretty well respected. I think I'll use that as the seed to build my own amplifier. And so what it ended up doing is I used the Ampex 620 circuit, the schematic for it, and I used the Ampex iron, and I decided that that would be a good place to start for the scratch build amplifier. As I said, I made a couple of changes to the circuit in order to have it work with full range speakers, which is what I do. So I had to remove the compensation circuit. I ended up removing some circuitry having to do with input switching, and also there was a tone control circuit that I removed as well. And I built all that stuff into a new chassis, and it was kind of my first go. Now, there were two of these, right? So they were mono. I had two. I couldn't very well build a stereo amplifier with only one of the transformers because the transformers would not have been rated from a current standpoint to deliver, to be able to feed all of those tubes for a stereo. So I ended up doing a dual mono amplifier. I could have done two separate mono amplifiers and two separate chassis, but I wanted to kind of retain one chassis. So my first build, the first scratch build that I've ever done is a dual mono 6V6 push-pull power amplifier, which I'm going to show you here in a minute. My goal, my intention here is to do a couple of things. One is to do a series of videos on a new amplifier build, okay? A new scratch build. Probably, in fact, I know it'll be a push-pull vacuum tube amplifier. But I wanted to start the first video or two of this series by talking about what I have already done. The decisions that I have already made with the first amplifier, and the decisions that I wish I had made differently, the changes that I would do for the next amplifier, and then spend the rest of the video series planning out the new amplifier, building it, and hopefully enjoying it. So that's the plan for this series of videos. And so in this first video, I want to talk a little bit about the amplifier that I have already built, my first effort, and we'll go a little bit through the circuitry of it as well, talk about a mistake I made. Actually, I made a couple of mistakes, and talk about what other decisions I might make with respect to this circuit or a different circuit for the next build. Okay. Okay, so here it is. This is my only scratch build vacuum tube amplifier. This one happens to be, as I said before, a push-pull 6V6 based Class AB amplifier. It includes a volume control, so I guess it's a little bit of an integrated amplifier as well, but it only has one input, so if I have to go back and forth between streaming something from the internet through it or listening to my phono stage, I have to switch out the RCA plugs in the back. As you can see, it's dual mono. It has two power transformers in the back here. Here are my output transformers. It is split right down the middle. The only parts of this amplifier that the two sides share are the power switch here and the AC input, and I guess if you want to consider the stereo volume control as well, though of course that's internally separated as well. This is based off of the Ampex 620 circuit, and so that circuit is I guess it's a fairly basic circuit. It seems to me that it's based off of the Mullard 510 circuit. There isn't anything particularly fancy about it. It uses a voltage amplifier in the front end, which is right here. This is a low noise pentode called a 5789, I believe. That goes to the phase splitter, which is back here. This is a 12AU7. And then, of course, the two phases are fed, the output tubes. As you can see, it's built onto a fairly large chassis. This is a simple Hammond chassis. I want to say it was $35, And this being my first build, I chose a large chassis because I wanted to have plenty of room inside to work. And in retrospect, I would have chosen a smaller chassis had I been able to do it over again. And of course, I will choose a smaller chassis for the next one. The problem with this one is it has a lot of open real estate on the top, and which I just don't think looks that good. It also flexes quite a bit, even though this is stainless steel. There's enough weight there that the chassis is actually pretty flexible. And then third, you could see here, it's 3 inches deep. I wanted that too because I thought I would need to have a lot of room inside, but it turns out I don't. I can get by with a chassis that's only 2 inches deep. So, you know, those are just little things that I probably would have changed if I had it to do over again. So let's have a look at the inside, and then we'll talk a little bit about the circuit, and we'll talk about some of the mistakes I made and some of the decisions that I want to do differently for my second build, which is the purpose of this entire series. Okay, here's the underside of the amplifier, and I'll just run through a couple of things that are sort of obvious and maybe a few things that are not so obvious. The first thing you'll recognize is that it's completely dual mono. I have no connection really between the left side and the right side other than the power switch over here and of course the volume potentiometer. I've also chosen to do this with a ground bus. So I have a piece of Romex, I don't know if it's 12 gauge, I think that's what it is, that runs all the way from the only point on the chassis where I have a solder lug for grounding, which is right under the power supply capacitors here. Then it runs, you know, over here to the on the right-hand side, near all of the circuits where things are going to have to throw up, you know, whatever components they have that need grounding, past the volume potentiometer, and then it is soldered at the end of the chain here to the to the ground of the speaker output. Okay, so there is only one grounding point, or at least I'd like to think that there's only one grounding point for each side of the speaker. There's actually, amplifier. There actually are a couple of places, unfortunately, where I think I might have a ground loop. And some of that has to do with my wiring. Some of it also has to do with the quality of the components that I'm using, particularly the RCA input, which is right down here. That is not isolated from the chassis. And so that's one potential point of concern. In any event, there's nothing very fancy about this. The power transformer is over here. Here is the tube rectifier. Here is the power supply. It consists of 4 smoothing or reservoir capacitors. Because this is a vacuum tube rectifier, the size of the first capacitor is limited. I believe this rectifier is a 6AX5. I believe the first smoothing capacitor can only be 40 microfarads. I'd have to look that up on the chart again and see. So I happen to have a 39, a 39, a 100, and a 47 here. And the rest of this is, you know, relatively straightforward. We have our power tubes here. We have the phase inverter tube here, and this is that pentode voltage amplifier over here. There is nothing at all fancy about the parts inside this this box. Okay, these are, you know, brown Nishikans. I got them off of DigiKey. I would be surprised if that represents more than $2.50 worth of electrolytics per channel over here. And these resistors are from a company called Just Radios, and you buy, you know, for $100 you get like 1,000 resistors and I don't know, you know, probably 100 different values. And I just use these. I think they're carbon. I think they're metallized carbon, if I'm not mistaken. And same thing goes for the coupling capacitors over here, right? These are the cheap from the same company as well. I would be very surprised if any of the if the total of all of the value of the components on the inside of this is more than $5 or $6. And in fact, the most expensive piece on this amplifier, if you discount the tubes, is this volume control. This is an Alps Blue. I believe it is real rather than a fake one that I got off of eBay, because I was able to get this from from Parts Express in Dayton, Ohio. I have no reason to believe that it isn't a real one. And it sounds pretty good, so I'm happy with it. you know, you can't tell by looking at the circuit whether or not it follows the schematic. You actually haven't seen the schematic anyway yet, but I will tell you, and we'll come back to this, that the one change I did make, and this was a mistake, and we'll talk about that when we get to the schematic, is I have rectified the heater supply. So this is the heater line over here. Okay, this was 6.3 volts, and I've brought it through a bridge rectifier. I've used a little bit of smoothing capacitance here as well, and then all of the heaters on this, you know, for all of the tubes are rectified, so they're DC. That turns out to have been a mistake. Not only was it not necessary, probably, but it probably made things worse, and I'll talk a little bit about that in a minute. In any event, this is the underside. You know, I'd like to think it's pretty neat and tidy. I think it basically is, but you know, there are some other things that I certainly want to change for my next build. Let's look a little bit at the circuits for this. Again, none of them are particularly fancy, and talk about some of the mistakes I made and some considerations for the next build, which is really the purpose of this video. Okay, so this is the schematic of the power supply for this amplifier. You can see in the upper left-hand corner I've written the Ampex 620. It's either the 620 or the 621, and this circuit really comes right out of that schematic with one minor change, which I'll talk about. But otherwise, as far as I'm able to tell you, based on my experience, which is not very long, okay, so it doesn't mean much, this is a super simple, basic power supply. There's nothing fancy about this at all. And so we can just talk a little bit about it as we run through. You can see the AC input over here. I'm showing a switch. I also have a fuse over here. I just forgot to put it on the schematic that I drew up here. You'll notice that the input voltage is 117. Well, when this amplifier was originally built, the Ampexes in any event, the voltage would have been about 110. So 7 volts doesn't seem like very much, but when you've stepped it up 5 or 6 times, that turns into, you know, 35, 40, 50 volts on the other side. Ordinarily, however, that doesn't represent too much of a problem for the amplifier because usually the voltages stay within the tolerance of the tubes. So I usually don't have to make a change to the dropping resistors for a situation like this. It uses a tube rectifier, which is right here. That's the 6AX7. You'll notice the 2 plates here. This is an internally connected, or a directly heated, I guess I would say, rectifier tube with the cathode connected to the heater supply. And right off of the heater supply, obviously, we have a high voltage. 345 volts is the highest voltage in, you know, DC voltage inside the amplifier. That feeds the primary of the output tubes. And then through a series of dropping resistors here, here, and here, we get successively lower ones. 335 volts for the screens, 250 volts. This is for the phase inverter phase. 180 volts, I think, feeds that voltage amplifier pentode sitting at the front of the amplifier. Now, here is where I made a mistake, and some of you who are eagle-eyed and are thinking about this can probably predict the mistake that I made. So you'll notice that this vacuum tube, at least in my experience, is unusual in that it is heated with 6.3 volts, or maybe it's 6 volts, I'm not even sure. But the vacuum tubes I'm most familiar with are usually 5s, the 5AR4, for instance, being, you know, sort of a prototypical example. And so the power transformer typically has a 5-volt secondary and a 6.3 volt secondary. Well, this power transformer, both of the secondaries were 6.3 volts. And one of them, as you'll see, I've drawn it right here, is center tapped, and the other one is not. I've drawn the schematic correctly, but I wired it incorrectly. I am almost certain inside my amplifier here that I have the rectifier heater on the center tapped secondary, whereas I have the heater supply for the rest of the tubes on the one that is not center tapped. And that's a mistake because my heater chain for all of my vacuum tubes, and they're just wired in parallel, means that it does not have a ground reference, okay? So that also means that that's kind of floating. I don't know where it's floating to, but there's no ground reference for it. So that's a wiring error, and in order to fix that error, which I may or may not do because the amplifier sounds pretty good as it is, I'm going to have to extend some leads, and I hate extending leads off of transformers. It's a miserable experience, and so I'm figuring out whether or not I need to do that. So that's a wiring error. That's relatively trivial. I think I can probably fix it. But the other error is also easy to fix, but not as trivial. And that is what I have done to the heater chain down here. So in the original schematic, it is AC, okay? It is simple. It just feeds off of, it just, you know, that this 6.3 volt secondary just feeds the entire chain. And as I said, all of those tubes are wired in parallel. Well, I've rectified it. I used a simple, cheap bridge rectifier here. I've got 2200 microfarads of smoothing capacitance there. In retrospect, that should have been closer to 10,000 microfarads, but be that as it may. Here's the issue, an issue that I had not thought about. When you feed heaters with AC, okay, and the way this amplifier and power transformer was designed, it's going to draw a certain amount of current. And in this case, by the way, it draws about 1.5 amps. I've done the math, and all of the heaters for one side of this amplifier draw, not counting the rectifier tube, draw about 1.5 amps. So I'm going to guess that this the secondary on the power transformer was probably rated for about 2 amps, maybe a little bit more, just to give people a little bit of leeway. Well, because I have rectified it, however, the heater chain is likely to draw more than 1.5 amps. In fact, I am concerned it's probably drawing closer to 2.5 amps, and that's bad because that secondary is almost certainly not rated for that much current. And as a result of that, this is my prediction. This is what I think has occurred. As a result of that, although my amplifier is electrically very quiet, and it sounds really great, mechanically it's not quiet. The power transformers hum quite a bit, and you can hear that humming from across the room. You can't hear it when music's playing, but you can certainly hear it when music's not playing. And I'm going to guess that because these rectified heaters are drawing more current than the power transformer was originally rated, that's going to cause two things. One, it's going to make the power transformer hot, and it is hot because I'm drawing so much current. And number two, I think it's going to make the transformer hum or buzz more than it otherwise would. So one of the things I'm going to do today, actually, after I'm done with this video, is I'm going to take those heaters off the rectifier and put them back on AC and see if that does anything to my mechanical hum. And I'm hopeful that that's not going to increase the electrical noise of the amplifier. One thing I'm considering is taking all of the vacuum tubes and putting them on AC except for that front end pentode. Maybe I'll keep that one DC. And that way I'm not drawing very much more current than the amplifier was probably originally designed to supply. All right, so let's look next at the circuit real quick, and then we'll kind of come back and conclude this first video. Okay, and so I've drawn out the basic amplifier circuit for this amplifier as well. As you can see in the upper left-hand corner, again, I've drawn Ampex 620 because that is essentially what this amplifier is. A couple of tweaks here and there that I made changes to, but at the end of the day, I use the schematic from the Ampex 620. I would tell you, however, as far as I can tell, that this is itself based principally off of the Mullard 510 circuit. Okay, so I don't think Ampex was inventing anything new either. In any event, as you can see on the left hand side, I've got my signal input here. It goes through the volume potentiometer here into the signal grid of this voltage amplifier pentode, the 5789, and the screen of this, okay, is held at 40 volts. And the way that it's being held at 40 volts is because it's in the middle of a voltage divider, 120K up here, 33K here. That is one way that Ampex did it. It is not the way that Mullard did it. I believe Mullard lets that screen kind of float around wherever it's going to be by not using a voltage divider there. But this does. Now you can see that the 5789, so this voltage amplifier, is DC coupled or directly coupled to the 12. I have 12AX7 up here. It's actually a 12AU7 to the dual triode here, which is being which is the phase inverter. So I have 100 volts on this screen. Now the screen down here is kind of decoupled from it, and of course it's losing all AC to ground through this capacitor here. This is, and the cathodes are connected together and to ground through this 82K resistor. So this is what's called a long-tailed pair. or a differential type phase inverter circuit, and I guess it has a little bit of gain, unlike the concertina circuit, but it's relatively easy to implement and it works fairly well. Now there are a couple of changes that I would make if I had to do over again. In fact, I am going to do some of these things over again in the new build, but I'm going to change a couple of things if I continue to use this kind of phase inverter. One thing that I would do, of course, is I would put some sort of a potentiometer down here in the plate supply, resistors, and bypass it with a fixed resistor as well. And that way I'm able to kind of adjust the plate supply voltage on one of these. It could be this one or this one, it doesn't matter. And that way I'm able to adjust the AC balance for the half waves that come off of the phase inverters. And then from there it goes into the push-pull 6v6 circuit over here. You can see this is relatively simple, right? It is a cathode biased. These are beam tetrodes. So this is cathode biased here. It has a cathode bypass capacitor here, happens to be 100 microfarads. In this case, I believe the original circuit called for 20 microfarads or maybe 22 microfarads, and I can tell you that when I had that, this amplifier had no base, it had no weight to it, it had no body to it. And through talking to people on Audio Karma, which gives me most of the advice that I need when I went through this thing, the folks there told me that I needed to increase the size of that capacitor, because I guess what was happening was something called cathode degeneration. In any event, that made all the difference. So that was a huge improvement. In any event, you can see here the screens are tied up to the 335 volt takeoff of the power supply, and here is the center tap of the center tap of the primary of the output transformer here. I have not drawn in the circuit for negative feedback, but it comes off of the 8 ohm tap here, and I can tell you, and then it feeds in over here to the cathode of the first stage. I can tell you that feedback circuit consists of a 33 kilo ohm resistor and I think 80 or 150 picofarads of capacitance bypassing that resistor. I'd have to look at that again. Okay, so that's the basic circuit. Okay, so you've seen the amplifier that I built, my first one and my only one so far. You've seen the circuits that kind of go with it, and I just want to sort of round out this first video with a discussion about what the future holds for this project. As I told you before, my reference amplifier stuff, the stuff that I listen to upstairs, is by a small Japanese company called Lieben. I have the small integrated amplifier, the CS300XS, which is EL84 based, so 6BQ5, and I also have their standalone phono stage. I have always liked the sound of the EL84. As a matter of fact, I think that the EL84 tube, the power tube, is the best sounding tube for my ears that I've listened to. I just like the way it sounds. I like it better, vastly better actually, than the EL34 tube and the other tubes that are in that class, the KT66, the KT77. I've not heard the 88 or the 120, so I shouldn't comment on that. I definitely like it better than the tubes that were being typically used in the Fishers. I think they're 5791s. There's a 7868s, which is the equivalent to that. I like it better than the 7355s. I have a couple of amplifiers that use that one as well. I've liked it better than almost everything that I've really listened to, at least in terms of push-pull, okay? Until the 6v6. As I said, I stumbled across the 6v6 only because that was the kind of amplifier that was in the Ampexes, and I have really liked it. one of the advantage of the EL84 tube is I find it pretty punchy in the bottom end. It doesn't go super deep, but it's punchy. It sounds great. But mostly, it has a really neutral, clear, expressive mid-range. And my listening biases are that I like, if you get the mid-range right, then I'm happy. And the EL84, to my mind, just does that better than the other tubes that I've listened to. That is up until the 6V6. Since I discovered that tube, I have liked it as much as the EL84. Matter of fact, I like it a little bit better than the EL84. I think it has it's a little bit more ballsy. I also think that it is, I like the way it looks better. So it's a larger glass tube. It's in an octal base, and just from an aesthetic standpoint, I prefer it to the EL84, and that is why I did my first amp with this tube, and why I intend to do my second amp in this tube. And so, I might have said earlier in this video that I have made very few decisions with respect to what the second build is going to look like and what it's going to consist of. However, I can tell you that I've made two important decisions. The first is that it's going to be a Class AB push-pull vacuum tube amplifier, okay? And the second decision was that it's going to be based on the 6V6 tube, probably because I've already done one build, and I want to, my personality is if I'm mostly successful on something, then my next project will be the same thing, but, trying to work out all of the bugs. And so that's what's going to happen. So I've made those two decisions, 6V6, push-pull, and because I've made those decisions already, that means that I can already go out and buy the transformers, and I did. In fact, just yesterday, I took delivery of a set of transformers for the new build, and this is going to be a decided step up from the build that I've already done. I can tell you that the transformers that I bought are from a Japanese company called Hashimoto, and there's a couple of reasons I chose Hashimoto, one of which is they have an American distributor. I put in the order, and 10 days later the transformers were at my front door. So that was really great. I love the way they look. Again, from an aesthetic standpoint, they look really great. My understanding is, just doing a little casual research on the internet, is Hashimoto is sort of the successor to the Sansui transformer business. Now, I don't know whether or not Hashimoto just bought the intellectual property, or whether or not it actually is related to Sansui in some other way. But from what I'm able to tell, that's what these are. But by any account, these are well-respected transformers. It also means that they cost quite a bit more than Hammonds, for instance, or Edcors, which are readily available here in the United States. So quite a bit more, actually. But I think at the end of the day, though, I think I'm going to be, pretty happy with the end product, and I hope over the next, 7 or 8 videos, we'll go through the entire build from design to hooking it up to the stereo upstairs, and having a listen. Okay, well, thanks. We'll see you next time.